In this video, we are going to discuss the insertion sort algorithm. Now, in insertion sorting is performed by inserting each element at its proper place in a sorted list. This sorting is based on a simple technique that is used by card players for arranging their cards. Now, suppose a card player has these cards and he has arranged them in proper order. The new card that he receives is this, and he has to place this card among these cards that he has already arranged. So the process would be, now 10 is greater than 5, so 10 is moved this side. 9 is greater than 5, so 9 is moved this side. 7 is greater than 5, so 7 is moved this side. Now 2 is less than 5, so the proper place for 5 is found. 5 is inserted here. Now the new card is this. Now 10 is greater than 8, so 10 is moved this side. 9 is greater than 8, 9 is moved this side. Now 7 is less than 8, so proper place for 8 is this, so it is inserted here. So we can see that the technique is to place the new card at its proper place in the already sorted cards. Now let us see the whole procedure of the insertion sort algorithm. This is the array A of n elements that we are going to sort in ascending order using insertion sort. Now in insertion sort, we'll consider our array to be divided into two parts. One is the sorted part and one is the unsorted part. And in each pass, we'll take the first element from the unsorted part and place it at its proper position in the sorted part. So now in pass 1, our sorted part is this and unsorted part is this. And the first element of the unsorted part is this A1 and it is placed at its proper position in the sorted part. So the result of pass 1 is that this becomes the sorted part and this becomes the unsorted part. Now in pass 2, the first element from this unsorted part is inserted in this sorted part at its proper position. In pass 3, this is the sorted part and this is the unsorted part, and the first element is A3 and it is placed at its proper position and in this sorted part. This process continues till the last pass, which is the n-1th pass, and in this pass the element an-1 is inserted at its proper position in this sorted portion. So after n-1 passes, the whole array becomes sorted. We'll take an example and see how insertion sort works. Now this is an array of 8 elements and we'll sort it in ascending order using insertion sort. And pass 1, this is our sorted part and this is the unsorted part. And the first element of the unsorted part is 23 and it has to be placed in the sorted part. Now 45 is greater than 23, so 45 is moved this side and 23 is placed here. Now in pass 2, this becomes the sorted part and this is the unsorted part. And the first element from the unsorted part is 32. So now 45 is greater than 32, so 45 is moved this side. 23 is less than 32, so 32 is placed here. Now in pass 3, the first element from the unsorted part is 10 and it has to be placed in this sorted part. Now 45 is greater than 10, so 45 is moved this side. 32 is greater than 10, 32 is moved this side. 23 is also greater than 10, so it is also moved this side and 10 is placed here. Now in pass 4, this is the unsorted part and this is the first element of unsorted part. It has to be placed in this portion. Now 45 is greater than 30, it is moved this side. 32 is greater than 30, it is moved this side. Now 23 is less than 30, so we'll stop and place 30 here. Now in pass 5, 12 has to be placed in this sorted part. So 45 is greater than 12, it is moved. 32 is greater, it is moved. 30 is greater, it is moved. 23 is greater, it is moved. Now 10 is less than 12, so we'll stop and place 12 here. Now in pass 6, 66 has to be placed in this sorted part. Now 45 is less than 66, so we need not move anything and we go to pass 7. In pass 7, 28 has to be inserted in this portion. So 66 is greater than 28, so 66 is moved here. 45 is greater than 28, it is moved here. 32 is greater, it is moved. 30 is greater, it is moved. Now 23 is smaller, so we'll stop and insert it here. So after 7 passes, the whole array has become sorted.